let's get a sketch going here. So I've got my axes, and then first up I'm going to draw C1. So this circle with radius 5. Yeah, I'll draw it quite big. Seems to be like the largest circle on here. And I'm also just gonna, yeah, there we go. It looks a bit more in the center now. I'm just gonna also draw a box around it. Okay, make it blue. Right, so this is 5, 5, then we got -5 and -5. Just put some, because then we're told a second circle C2 has radius 4, center AB, where A is between -2 and 2, and B is between -3 and 3. Right, so I'm now going to draw another box as the different positions where the center could be. So it's going to be this rectangle that I'm kind of constructing. Okay, so that's the different regions that I could put the center in. And then if the center is equally likely to go anywhere within the given range, what's the probability that this circle intersects C1? So what I need to do is find now the region where it would, like, for example, if I put the center here, remember the radius is 4, it's definitely going to intersect. So if I look at distances that are 1 away, like here, for example, that's when my circle of radius 4 is, it's going to come, oh, sorry, I didn't mean to do that. So it's just going to touch at that point. But if I moved it slightly to the left, then it wouldn't. Okay, so that's kind of a boundary point that I've just put in. And then there's also going to be one here. So again, it's 4 away from the edge of that circle. Then I'm also going to need to have one here and one here. But if I think about this, I can't put one here because that would actually, that distance would be root 2. Would it? Yeah, root 2. And then I would actually be less than 4 away. And what we're actually going to need is basically to look from this point here a distance of 1 away from it. And we're going to create another little circle. So if I put my center anywhere inside this circle, not on the very edge. If I put it on the very edge, it's just going to touch. But if I put it inside, it is not going to intersect the blue circle. If I put it anywhere outside the circle, it definitely will. Like if I put it over here, then we are well below 4 there. So we're actually there. I hope this makes sense. I've drawn my original circle. I've drawn this region where I could put the center, and then I've thought, right, where in that little region can I put different centers? It's like a locus of points, such that it will just touch the blue circle. So I went 1 away, up, down, left, right, and then I also then had to, it's not going to be a square, I had to draw a little circle within it, because if I put it there, then I've got a distance of 1, and then that's 4. Okay, so that's why if I put it on this very bit here, it would just touch, but if it's inside, then I'm okay. So we're kind of there because what we have is, right, we want the probability that C2 intersects C1. So it's going to be this area in green divided by the whole rectangle area. And this length, it was -2 to 2, so it's 4. This is 6. So we're going to be dividing by an area of 24. And don't worry about like the very boundary points, that doesn't come into it. And then it's going to be 24 minus the area of that circle on the inside. Well, it's pi times 1 squared, it's just pi. And that It's all come together. That is our probability. The answer is F. Oh, well done.